slides. Yeah. Okay. I assume this is readable. Okay. So as you know, I've done a bunch of Nix refactoring recently, and I've managed to learn a bit about Nix in the process. And I know that a lot of you are kind of wary of Nix and touching any of the Nix configuration. And that's understandable, especially based on how it was before, which was just a mess and very hard to get through. So I'd like to explain to you the basics in this presentation, go over all the syntax, how the derivations work, how we can make shells, how Nix packages work. And then in a separate presentation, I'll go over in more detail how all of this goes together in Status React. We'll hopefully have some time at the end for questions, but if you find that anything is unclear, then feel free to interrupt me. Although I would prefer if for the time being it would be muted, because I am streaming, so it would be better. Okay, so first of all, what is Nix? Nix is just a package manager, which is just trying to solve the age-old problem of dependency definition and management for software. Pretty much all software depends on other software, and in general, it's mostly an acyclical graph with some small exceptions, and those exceptions usually make it so much worse. And there's been so many attempts to make package management work, and there's no perfect solution. Nix is just another one of them. There's some exceptions in terms of cyclical elements in the graphs, like compilers. That, for example, GCC needs GCC to compile itself, but there's not that many examples of cycles like that. But in general, that's what it was made for, and it's made with a subset of Haskell, functional programming language. I don't know why, but that's what they picked. And it's actually spiraled out of control, and now it's a full-fledged operating system. I think it's pretty cool. So let's start with basic syntax. Of course, we have null, we have some booleans, we have some integers, floats, what have you. You also have strings with interpolation syntax, so you can put strings inside of strings with essentially the curly brace like in JavaScript. You have lists with mixed types, so you can put anything you want in there. You have sets where keys are always strings and the values can be any type. It doesn't care. And there's a special type of path, which is kind of different from string, because if you specify a path of an existing file, it will just put it in the Nix store before it's available during build or in the shell. And there's also another special type of path, which is enclosed in square braces, which is Nix packages, which is just an easy way to provide Nix packages for you whenever you're building stuff or just trying stuff in the shell, and it's found through Nix path. And that's really all there is to it in terms of types. And strings have like a multi-line syntax where you use twice single quote. But it's all about functions, right? Because it's a functional language. So functions are defined with a colon after the argument. It's pretty simple. Like, let's do a repl, so it's easier to explain. I assume this is readable, right? And we can just do like a double equals x times 2, and double 2 should give me a 4, right? And it's just a single argument function. We can do a 2-argument function by just doing like x, y plus y, and to add 2 should give me 4, right? And I think this works similarly in other functional languages where this is two functions rather than one with 2 arguments. There's a first function with argument y, which assumes that x is available, and there's another function that wraps it and calls y by providing x. So I could do like add 2, which would give me a lambda, and I could apply that to something, and then call add with another, let's say 3, and I should get 5, right? So the I is the partial lambda inside without the first argument, right? But really, the main way you provide arguments in Nix is with a single argument that is a set. And the main advantage of that is that you have named arguments, which is easier to manage, and you have default values. So we can rewrite the add function by just providing a set with a with a default value of 2 and, actually, we're using x, so let's use that. And y with a default value of 2, and let's do x, y. And if I if I check it, it's a lambda because I need to give it an argument. So let's give it an empty set, and I just get a 4. And I can give it an x equals 3, and I should get a 5, right? I could try specifying a non-existent argument, but that would fail. There is a way to go around that. Like you could just do like for the triple dot syntax, which allows me to do that, to just answer the default and ignore the A. But that's a very edge case. You usually wouldn't use anything like that. And sets are the main way that arguments are passed around in Nix. Only small utilities and libraries use the positional arguments, which can get messy, especially when you have too many arguments. Now, let's do a bit of a complex expression. So files in Nix are always an expression. They can be a function, or they can be just a value returned from the expression. They usually are a function. So let's do some examples. Here you can see that the argument is a set with input. As a default is a string called default. And we return a set that is defined in the let block, which is like a space where you can define stuff before you return it. And some other examples. So let's do that right now. Let's do like here stuff. So an example, default Nix, for example, and I could just return a set like this. For example, a string equals something, right? And this would just be a set. Let's do Nix. And I can interpret this using Nix instantiate. This is like it's the simplest way to essentially call a Nix expression. So I can do Nix instantiate eval strict default. And I should get, yeah, let's do Nix fmt for nice format. Yeah. And actually, I don't need to give a default because that it would use default file by default. Now, I could make this into a function with an input default. And we could use it here, for example, with an interpolation. But if I called it, it would just be a lambda. So this is kind of a weird thing in Nix instantiate. I don't know why it does that, but you have to give it any argument. So let's just give it whatever argument. I don't care. Yeah, and we get something with interpolated default inside of it. Actually, let's do ls enter bash c. Let's close this. Yeah, let's add a clear too. Yeah, that's gonna be simpler. So we could add some more stuff like a list, for example, 1, 2, 3, 4, and then input to mix stuff. And we'll get a list with fifth argument being the default, right? If we wanted to, we could define this before returning them. And we could return a set with, for example, just a string, right? And we would get only the string. But there's a simple way of doing that. You can just do inherit string, and you could inherit a list as well, right? Or input itself, right? And get all of those. And in general, this is usually the way you do it, unless you want to change it, because you could do something fancy like a list equals like 5, 6, 7 plus the a list we defined before. And you would get a combination of all of those, right? Now, this is essentially the way most derivations or any expressions work. You have inputs, you have some pre-prepared variables or functions that you use, and the actual return value, which is either a value or maybe a call to some function that returns a value, something like that. Now, and there's also a JSON flag if you want more nicer output. And we can specify a different argument. So, for example, we could do arg string for input, and let's say whatever, and then whatever is put in those places. So you can pass argument through Nix instantiate to modify the specific expression you're working on. Now, the other crucial part of Nix language is import. You can import another file into the file, either as data or as a function, depending on what the file contains, to essentially split stuff. So, for example, if you wanted to put this list into a separate file, we could do a separate file like list Nix, for example. We could take this list, put it here. Let's just do the list alone. I just do list import, yeah, like this. It should work, right? It does work because we're just loading it. But let's say we did want to input to be here, right? It would fail because it doesn't have it. So we'd have to specify input as an argument without default in this case. And this would fail because we're not passing the argument. So we'd have to do like inherit input. Oh, wait, wrong place. Inherit input. Oh, always forget the colons. Yeah, and now it works. Now the input is passed in here within this list. But if you're doing something complex and you have multiple files, then this can become quite big, especially when you have like multiple additional things, right? So it becomes very, very verbose very quickly. So what you can do, and this is kind of a trick that is used all around the Nix, you can create a new scope. And for this, we'll need packages. So we'll need to import packages. Let's do that. PKGs, and the default value will be import PKGs, Nix PKGs. There's no configuration. And we can do something like call package, which would be a function, which we define as PKG's new scope with inherit input. And then instead of using import, we can do call package. And we can get rid of this argument, and it should still work. Will they break? Of course, every time with a semicolon. And it works because the call package provides the arguments by default through inherit here in the new scope. And I could add here much more stuff, right? So if I have the multiple call packages with that require the scope, it would be much simpler. And this is the way essentially packages are passed around in Nix. As it's a bit of a trick that you normally see where it's defined, because the new scope is rarely used unless you really have a special case where you're importing a lot of files or something like that. And this is mainly used in something like all packages, and we'll talk about that later. But it's essentially a place where all of the Nix packages are defined. Now let's get to a derivation. What is a derivation? Derivation is just an Nix expression which defines all of the necessary inputs to build a specific package, like build tools, compilers, libraries, sources, build scripts, environment variables, and all of those are predefined, which most of the time makes the packages built deterministic, because all of the inputs that you use to make the package are predefined in this Nix format. And Nix has a built-in primitive called derivation, which you almost never use because there's a wrapper called mk-derivation that wraps around derivation that provides a lot of niceties around it. So let's take a look at an example package. You have a hello package, which essentially defines the package name, the version, the source. But it fetches it by providing a set to a function called fetchURL. With the URL and SHA and some metadata. And that's essentially all you need to pass to mk-derivation to get a working hello package. And we'll explain that in a second, but mk-derivation takes a bunch of arguments. There's much more than you would see in many derivations. Of course, you have the package name and the version, but you also have, for example, you can provide multiple sources. You can provide build inputs if you need additional tools to build the package. You can configure flags if your package includes a configure script, or provide a list of patches that you want to apply. And all of this gets combined into a derivation file or a DRV file that contains all of this information. Before we see that, let me just show you real quickly the file make derivation, because essentially what it is just a function which is defined in the Nix packages in std and generic, which takes a set with a lot of arguments, like, for example, build inputs here, a lot of arguments, and with some magic, when it like stews the arguments, at the end of it, it just calls derivation. So it's just a wraparound derivation that provides some additional niceties to make it easier to build packages. Now, let's take a look at the hello package example. So let's say, stop this for example for now. Let's go into Nix packages. And let's do Nix build. No, I think pkgs hello. It's building. I don't know, I removed it. But it actually, I could probably do the same thing with just build. Yeah, default. Yeah. So I probably modified the package, so that's why it's building. But let me see. Hello. Yeah. So we have the build result, and we can take a look at it. There's just there through, for example, bin, so we can call it. That's the binary for hello, and we can look at how the package is defined, right? We can just look in Nix packages. Hello, packages. There it is. That's essentially what I showed you. There's some additional metadata provided, and there's like a do check. But all it does is just fetches the source and runs the generic build, which is the default way Nix builds stuff, right? And I told you about the derivation. So each build package has a derivation that results in the package. So if we do Nix store query deriver, I think, on the package, we'll get the derivation file, which is just, if we cut it, it's just a bunch of data here that is used for building the package. We can show it in a nicer format with like Nix show derivation. And we'll see that it has the derivation file, the SDN, the tarball that it uses, the system target system version, package name, SDN it uses to build. So all of this essentially builds the package. So what I did before is I built the package with, for example, this. What I could do is I could just do this on the derivation file. Nix build, right? Well, they're actually different because I'm using packages here. So if I do without the packages, yeah, they're the same. So, and you can also query the derivation for additional information like name or SDN or SRC. But the main thing to understand is that the derivation is a collection of all of the inputs that are necessary to build the package. Now, why is hello being built, even though we haven't specified things like GCC or make? Well, because Nix provides something called the standard environment, an SDN, which pre-prepares all of the most usually used tools like GCC or make to the build environment. And we can take a look at this SDN by using the same command show derivation. So we can do just Nix show derivation. Nix packages, SDN. And SDN is essentially just a collection of various tools like patch, like gzip, like numake, GCC, of course, and a bunch of other stuff like, for example, the setup script that is used to essentially build everything. And we can take a look at the setup script, actually. The setup script is essentially the core of how Nix builds stuff. And it's not big, it's like 1,300 lines, but the core of it is the generic build function, right? Now, the generic build function is a function that calls all of the standard phases to build the package. So, for example, it calls unpack phase to unpack the tarballs, patch phase to apply patches if they are specified, configure phase to configure, build to call make, or like some additional phases like fix up phases if you want to patch binaries or something like that, and essentially provides the result into the output. And all of this is run by this function, generic build, which goes through a list of phases, which are predefined and can be changed. Lots of checks whether they should be run. And then, in this crucial place, it essentially runs either the default function or the provided phase that you've defined in the MK derivation. As it says, evaluate the variable name current phase if it exists, otherwise function name current phase. And we can see here that, for example, if you look at the build phase here, there is a function called build phase. And what build phase does is it essentially just runs make with some additional flags. That's all it does. Or if we look at configure phase, right here, it's another function that essentially just runs configure with some additional flags. Where is it? Yeah, JavaScript with flags. And that's all there is to it to Nix build. It essentially goes through the phases that are predefined and does the most common sense thing that you would do for a normal C package. So configure, make this, whatever. And all of these phases can be modified. So let's take an example of the hello package. Hello package doesn't change any of these phases. If we look at the hello package here, let's make it a bit bigger. If you look at the hello package here, it doesn't define any phases. All it does is just says that it wants to do check. And we can see that do check is here, and it verifies that the check phase should be run. But everything else is default. So if we modify this package, if we do, for example, if we create our own phases, let's say pre-configure phases, we can do pre-configure phases equals what the fuck phase, and we define our what the fuck phase as just echo what the fuck, right? And this isn't work. So let's say we want to build hello, but we want to use our version of Nix packages from, I guess, homework. So work Nix packages. So we've run this. It should start compiling. And as we see that it's running the what the fuck phase and it's printing what the fuck, right? And we can do more cool stuff here, because if we want to, we can, for example, change this to do something more useful, like show us the environment that is used for building this package. So to do something like env, and we run this, and there we have it. Here, and we see we have, for example, version specified, we have our phase specified, we have CC, some other stuff like like name. So it's very easy to debug it. Actually, you can even do something more fancy, like set X if you want to see all of the commands that are being run. And with set X, if we run it, it should be showing all the commands. And let's stop it. Yeah, so we can see, for example, here that's running configure with some flags like prefix to specify where the output should go. So it's easy to debug it this way. And you can do this with every other phase. Like if I wanted to break the build, I could do build phase and just do exit 1. And this would break the build phase, and it would just fail when it gets to it. It would go through the configure, and right after the configure phase, it would hit the exit 1. That's a lot of configure for a package that just prints hello world. Jesus. Why did it do this? Yeah, there we go. There we go. It failed. So this SDN is provided to all packages, and you can modify it, but in general, all packages are built with this standard environment. And we can explore the standard environment by using Nix Shell. You can use Nix Shell and call it for a specific package in order to see that environment that is provided by standard env and the definition of your derivation. So let's do it right now. Let's call this for now. Let's call Nix. Actually, let's call Nix Shell. What package is hello? Let's create a directory. And we can do type generic build. You can see that generic build is a function. It's provided here. And I can call it if I want. But I can also show you that we have std_env just here, which is the place that provides us the function, because we can see that it has std_env. There is a setup script, and that setup script is the one we were just looking at, and it's sourced before the shell is started, so it makes available all of these things like generic build, and it makes available all of the other things like name, or program name, or version, or our build phase, which is, as you can see, exit1, right? So you can very easily debug builds because, for example, I could just do eval on a specific phase. Like I could do eval configure if it was a string, but it isn't. In this case, I would have to call it like configure phase, right? Or I could just call generic build and let it build. Actually, let's fix it. Let's remove the broken build phase. Let's leave it as it was. Let's start the shell again. Let's go into tmp hello. Green? No, it's not green. Now let's do generic build. And that should essentially run the same thing that Nix build would run, except in a shell that at any time I can stop or add additional commands and explore what's happening and debug my build this way. And this will result in essentially the same binary that we would get from Nix build, right? Yeah, there we go. So now if we look here, we have hello. Bam, there it is. Yeah, exactly what they said. So you can call these specific phases by hand if you want, or you can modify them by hand. They're all in the environment, either as functions or as variables. They're just strings that you should eval. Now this is cool because you can do the same thing by making a specific shell for a specific function, because a derivation doesn't have to be. You don't need a derivation to make a shell. You can make a shell just by using mk shell, which is provided by packages. So let's do that right now. Let's leave the shell. Let's go into Nix stuff and then shell Nix. Let's do we run packages because we need the mk shell. So we import Nix packages. And let's do pkg's mk shell. Let's call it strace shell. And let's define build inputs as pkg's. Great. That's a column because these are the arguments. Right? So this is the set that is the single argument to the function that returns the result of calling the function mk shell, right? And I'm saying that pkgs could be specified, but I'm giving a default, which is just the default pkgs you would normally get, right? And now I can just say in my build input I want a strace. This is just a fancy way of saying pkgs. If you have more of them, it's nicer. So now we can, let's go on. Let's make Nix stuff. Let's do Nix shell Nix. We have a new shell, and we can do which strace. And we have the strace available as we defined, right? But we could do some more cool stuff by using something called the shell hook, because the shell hook is essentially called whenever the shell is created. I can, for example, show a message. Hello. So let's recreate the shell. Actually, we don't need to specify shell Nix because Nix shell uses shell Nix by default. So we can just call Nix shell, and we can have it. Prints hello. We could even specify environment variable. So we could do export a message and then call message. Start the shell again. Have hello, and I can do message. There it is. I can do more fancy things like export strace. Which strace shell Nix trace. There it is. So shell hook is a way to essentially pre-prepare your shell if it needs additional environment variables or anything like that, in addition to the tools you're providing, right? Because you can easily expand this by adding additional tools like I don't know, Gradle. Right? So we started, and it should switch Gradle. There it is. And you can make these shells for specific purposes without having to make a derivation. But in reality, MK shell is just a derivation. And let me show you what. Oh. MK shell. Yeah, there it is. So this is the function that defines the function called MK shell. And as you can see, it is just an MK derivation, which is called Nix Shell, with phases set to a single phase, which is no build phase. And the no build phase just says this derivation should not be built, and this fails. So if I try to build the shell Nix, with Nix build, it would fail. The derivation is not meant to be built because it's not supposed to be built. And this is exactly what we saw when we were looking at setup sh, right? In the generic build, the phases is a list of phases, and because in here we specify phases as just one phase, no build phase, then this is essentially just no build phase, which iterates over it and calls only that specific build phase, which only results in this echo and this failure. So Nix Shell is just a derivation that is not meant to be built. It's actually pretty clever. Okay. Yeah, what's over that? Sure. Yeah. Now, I've mentioned Nix packages a lot, and Nix packages is essentially just this huge Git repository which contains the definitions of derivations of all of the packages that Nix uses or NixOS uses too. And all of it is essentially pulled in one place, which is in packages top level, all packages Nix, which is a huge Nix file, which is just a bunch of call package to different subdirectories which define specific packages. Like in here we have different fetch functions. Before we saw fetch URL, then you also have fetch from GitHub, right? So if you look at, for example, the hello package, if hello package was hosted on GitHub, we would just change this to fetch from GitHub, right? And we'll do the same here. And we define like owner, repo, right? So no URL, and then like a rev, I guess. Same thing. And we will just get back an SRC that we can use in the build process. And I can show you this package. It's all packages. Yeah, there we go. And it's just a huge file full of call package. And we can find our own package, which we're playing with, which is hello, right here. It's just a call package to subdirectory applications Nix hello. So if we go up one folder, we go to applications, miscellaneous, hello. Yeah, there's our derivation, which I modified unnecessarily. Yeah, that's how hello becomes available when I call build pkg's hello, because it's defined in this huge file called all packages. And that's how all Nix packages are passed around. Now, Nix packages have ways to override them. So if we wanted to have a specific hello with a different version, we could very easily override it. But that's kind of beyond the scope of this presentation. Maybe I can mention that in another one. Things like overrides of packages, overrides of package arguments, overrides of functions for creating packages. You can override anything. But essentially, I could take the package for hello and modify the version and SRC and build with the same derivation a different version of hello. Yeah, so that's essentially all of the basic knowledge you need to get started with Nix. All of this is kind of hidden in the massive documentation that is available at nix.org. So I thought this would be a good primer. In general, I think Nix is a very powerful tool because it provides a clear way of defining how packages should be built and the hierarchy of packages and how they depend on one another. And it makes debugging builds very easy. It makes it also very easy to make shells for specific purposes, which is why I've started using it as my main operating system for both desktop and the server. But there is a problem. I mean, the documentation is massive. It's hard to search through. The syntax is unfamiliar to anyone that hasn't used Haskell. And there's kind of a chaos in terms of Nix binary tools. Like, for example, we have the Nix build and the Nix shell, right? But there's also another binary which is called Nix, which has sub-commands. So you could do Nix shell or Nix build. And they're trying to essentially wrestle that into order so everything is available under this one single binary Nix. But for now, the functionalities don't fully overlap. So you kind of have to switch between Nix-build and Nix build, and it's a bit messy. So it's understandable why it's kind of hard to get into it. And also discovering libraries essentially consists of browsing Nix packages and looking for examples of how other people did things, because there's no easy search. You just have to grep. But in general, I think it has a lot of potential, and hopefully with the next presentation in which I explain how all of this comes together in Status React, developers will be a bit more at ease with trying to modify it. Here's some resources. The main one I would recommend, actually I've put it at the top, is the Nix Pills one. It's like a series of lessons that gives you probably the best intro into all of these things, because the main documentation is massive. And there's these two videos which are pretty helpful for understanding how it works. And the discourse is quite nice. Usually people respond within a day, so the community is quite active. That's about it, really. If you have any questions, I'd be happy to answer them. Yes. It wouldn't, because the thing is, all of the Nix stuff is provided through Nix. So essentially, let me show you. If you go to Nix site, if you want to install it, actually, let's go to manual, maybe installation. What it does is it creates, well, you have to, unless you have permissions to do it. It creates a /nix where all of the packages are stored. And Nix, once installed, is just a set of these tools like Nix or Nix build, which don't use anything from the underlying system, essentially aside from the kernel, because everything is in the Nix store. So if we show derivation for SDN, if you look at that, for example, if you look at all these packages, all of this comes from Nix itself. Like the tools we use to build packages don't come from the underlying system. They only come from Nix. No, because essentially Nix bootstraps itself because it has a binary cache. So it provides all of the core utilities necessary to start building other things itself. And the way it works is essentially you have this repository in Nix KGs, right, which has it's just a Git repository which holds history. So you can, for example, bind yourself to a specific version of Nix packages, and none of the tools you'll be using for building will ever change, because GCC will be the same, the one defined by Nix, make will be the same, defined by Nix, and so on. Any other tool you will use to build any other package is defined by Nix and provided by Nix. So Well, in general, I think Nix should work on any fully fledged Linux or Darwin system. I've never seen it fail on anything like that. I've tried Nix, for example, on multiple architectures like ARM, and it does work, even it's slow because well, it does compile a lot of stuff sometimes. But in general, I've never seen it fail on any Linux or Darwin because it's all predefined, and the tools it starts with are also precompiled because they come from cache. So you have to try and see. Maybe you'll find something that fails. Cool. Any other questions? Yeah. In the chat or no? Why do we need to embed a Linux distro into another Linux distro? If we really do, why use Nix and not Gentoo prefix or other established distro inside the container? Good question. I actually, Nix started as something you install on top of existing OS because that was the easiest way to provide it. But I think the proper way is to just run it directly on the hardware. I run Nix OS myself. Like if you see name, I'm running Nix OS right now, and all of my packages come from Nix. So if I do like which xorg, for example, I don't know, xorg comes from current system, and there's probably a symlink to an xorg and Nix store. Yeah, there we go. So in general, Nix can run as its own system. The reason we run it as a subfolder on an existing system is because it's the simplest way to install it for developers. So if you want to, because I guess that's the decision we made. I used Gentoo before. A few years back, I used Gentoo as my main operating system for both desktop and Linux, and I liked it a lot. There's no clear reason. I assume we could do the same thing with Gentoo, although the thing is, I don't think we could use Gentoo as just an addition on top of the shells we're already using. We would have to run, as you say, inside of container or a virtual machine, which adds more overhead, and Nix just runs directly within your system without any containers or anything like that. So in that sense, I guess it's simpler to deploy than doing containers. But yeah, Gentoo would probably work as well. Yeah, but it would have the overhead of a container or a virtual machine. Yes, and there's a legality reason, like Pedro didn't choose Nix by himself. I believe Nix was proposed by Jared initially, and it looked interesting, and that's why we picked it. Yeah, the thing is, Gentoo is a full operating system, and Nix doesn't have to be a full operating system, because if you install it on an existing Linux operating system, you're not running a kernel. You're just running the binaries, like compilers and so on. So in general, the way you install Nix on an existing operating system is much lighter than if you use something like a container. It's much smaller. So yeah. Any other questions? No? Okay, cool. Well, hopefully this was enlightening. I will prepare another presentation probably next week to expand on that in terms of status React, and we can go from there. Hopefully this will help the developers be a bit less scared of Nix and maybe start modifying it. We'll see. Thank you very much, everyone, for coming. Cheers. Have a lovely weekend. Bye-bye. Bye. No problem. Cheers.